Hello there, everybody. Welcome to an introduction to linear algebra. As you can see here, Jigsaw, the infamous villain from the child-friendly series known as Saw, has attached a strange device to your hip. And personally, I don't know if you're carrying any peanuts in your pants or pockets, but if you don't solve the equation up above in 5 minutes, it will activate. I imagine that it might be painful considering how evil this guy is, but of course this is a really simple problem, a beginner's problem, that I stole from the source that I learned it at, and also in my notes. And you might be wondering about the system of equations here. You might be looking at this crazy thing thinking, how do I solve this? What does it mean? Well, we're basically trying to find out what x equals, what y equals, and what z equals. Let's just move this a bit here. Now, how on earth would you go about it? What you've learned in algebra is not exactly going to help you here, and I've already basically wasted 4 minutes, but don't worry. It's not like you need it, right? It's not like you need your peanuts, do you? So here we have this system of equations. If you try to, like, say, isolate the problem here, like, say you try to move z onto its own side, you get z equals, like, minus 1/4 x plus y. That doesn't really help you solve for what z equals. We want like an integer solution here. So then how do we go about solving this if we can't really isolate any of the equations, because like they all equal each other? If you want to go that path, go right ahead. You can do it in your notebook, you can do it on a fresh sheet of paper. Don't pull out Wolfram Alpha either, or else the nutbreaker device will activate immediately, because just specifically, fuck you. Why are you learning linear algebra if you're just going to use a calculator? You gotta learn how to do it yourself. Plus, if you gotta build your own fucking calculator at one point, you gotta know how to actually do linear algebra. And for those who are more clever, if you decide to pause the video and try to solve it on your own, or try and figure it out on your own, you might have noticed that maybe instead of thinking about it as trying to solve for the variables, we know that this entire equation that, x will equal x, y equals y, and z equals z, right? So then, maybe, perhaps, we basically, instead of thinking about this as a issue necessarily that, you know what? You're just gonna have to let the device activate while I explain this shit. So, instead of thinking about it by trying to isolate the variables, by moving everything to one side and solve for, just one variable, maybe instead we use this entire thing here. This entire thing. And we just focus on try and subtract the entire things in of themselves. Because here's the thing. We know that 0 equals 1/4 x plus y minus z. We know that 12 equals x plus 4y plus 2z. And we know that 2x minus 3y minus z equals 3. What do you think that might lead to? How do you think you might go about it now? Now that you do have the luxury of like solving this and pausing the video and solving it in 5 minutes, so I'm pretty sure that the hints I've given to you should be enough to help you deactivate the nutbreaker device attached to your hip. I will just have to take the blow. Suffer the pain of being a teacher, then again, I guess dealing with, like, unruly school children who don't really like to learn is another fucking pain. But, look, so now we know that all this stuff is here, you know, just like is right here. So, okay. Alright, so we know that this all fucking equals 0, so then maybe we can simplify this shit a bit. We can fucking, right here, you know, since all this equals 0, if we multiply both sides by 4, right here, we can make something easier. Right here. It's basically, if we wanted to write it, this operation here that we're kind of doing, we kind of do like 4, and right here, we're multiplying the first row by 4, the entire row, and so we basically get x plus 4y minus 4z equals 0, because, you know, if you multiply both sides by 4, 0 still stays 0. It still equals the same thing. It's just being multiplied, so all this equals 0. Isn't that neat? You know? And now we have this, and then we also have all of this that we want to have. You know, it's right here. Let's move all this here. And so what do you think you can do with this? What do you think you can do with this? Now that we've simplified it a bit. I already mentioned that we're going to try and, like, use this full equation here, right? To try and solve for every single variable. Technically, I guess I don't really need to worry about solving this because it has already activated on my dick. But you see here that these things right here, you see this? Isn't this interesting? They both equal each other. What can we do about that? What can we do about that? Well, so, oh yeah, I guess I should probably note, this is what we would, you know, we have to simplify the, you know, this is linear algebra, we will do it with matrices and stuff like that. You don't have to worry about this quite yet, but for what it's worth, right now, I want to show you how to do it without a matrix, and make you understand how useful the matrix notation is in order to solve this. Because here's the thing, I don't think you know, it's like a nice way to get into the matrix notations and like how it looks by easing you into it, by trying to show you how overcomplicated all this mess is, because there is a simpler way to solve this. Because, let's see, I want to, you know, in order to basically isolate this variable here, these two are like the only two differences here. Wait a minute, what do we notice here? And these two are the same here. So why don't we use like a different color here to kind of like show you, like these are the samey, or maybe a green one would be, yeah, this is a good enough color. Yeah, these are the same, you know, let's go ahead and show this, and then orange for, these are different. And these are different. So then, what can we do here? Suppose we subtracted, you know, because we know that if we, you know, we know that x plus 4y minus 4z equals 0 and x plus 4y plus 2z equals 12, then we can basically say that, well, let me write it out real quick. This is gonna, we don't have much space here, but we can make do, you know. So basically, x plus 4y minus 4z equals 12 minus 12, and all of this stuff equals x plus 4y plus 2z minus 12. This is 12. So then, these two things here are the same. So, wait a minute. We can now isolate this. We just cross these out. If we move all this to this side, we basically, we also have to subtract this as well. Let's move the z all onto one side. And then we basically get, we can also go ahead, because the result, we're basically subtracting 2 from this, so then we get 6, and then it's like minus 12. So we can go ahead and like also do a little bit of add here and then add here. We just like multiply both sides by -1 after, everything after all the results here, we just multiply by -1. That's our goal here. So then we get basically 6z equals 12. And so if we were to simplify it, we get z equals 2. Because we divide 6 by both sides. Wow, look at that. Z equals 2. And now all we have basically is this here. But wait a minute. We still have like all this weird stuff here. We have, if we just substitute z in, we still have this left. This annoying problem here. So, if we have like 2x minus 3y minus 2 equals 3, we still have like 2x minus 3y equals 5. How do we isolate that? We want to solve for the variables as well. This isn't a function we're trying to solve for. We're trying to solve for like the actual variables here, right? So how do we go about doing that? Well, we basically have already done a fair bit of stuff already with this. We basically subtracted this row from this. We're basically, oh, whoops, let's not zoom in that close here. I accidentally somehow did that. I have no idea how to use the software quite yet in its fullest capacity, but, So, we basically subtracted row 1 from row 2. Again, this is just a notation to kind of, you don't have to worry about it too much, but just think of like, this is the second row because of the number 2 on the subscript, and this is row 1 on the, because there's a 1 in the subscript, the thing to the bottom right there, if you didn't know what a subscript was. And we basically have a little neat thing right here, where we basically have x plus 4y minus 4z, and then we did like all this stuff here, so then we basically got like z 0 equals 0 here equals 2 here, and let's erase this real quick. You know what we did, so I don't think you need to worry about it too much. And we still have 2x minus 3y minus z equals 3. Now, what can we do here? Well, we can use the z and completely remove the z from the other equations, right? We can basically do this same thing effectively by just simply minus 2, or no, actually, since we are basically adding 4z, and we're basically adding 4 times 2 here. So we basically add 8. So then we basically have like x plus 4y equals 8 here, because this is a negative, we want to get rid of it, so that all cancels out. And with this one here, you know, we basically do the same thing. We basically add 1z, and we also add 1, 2 on this side. So we basically get 2x minus 3y equals 5. That's pretty cool. Now, the problem is that you might have noticed that these two don't equal each other. That's a bit odd. So these two don't equal each other, and neither do these, because it's 4 and 3, 1 and 2, and 8 and 5. Actually, if it were like, if these two were the same numbers, then I get the feeling, yeah, no, I think that might be a bit hard to solve. Well, actually, no, it's simplified to like 0 for both. No, wait. Yeah, no. Don't worry about it. I'm probably forgetting some of the stuff that I've learned in linear algebra. It's been a while since I've actually continued my studies on it. But, so we're stuck with, like, this equation here, that, like, none of these actually equal each other. Now, we could just, we could try and do something like, you know, 8 equals 5 plus 3, so then, you know, we can do something like x plus 4y equals 2x minus 3y plus 3, and then solve for all that. But there is also a simpler way again, because here we just added both of the rows up above, and we can just go ahead and simplify all this crap here, just this 2 crap. There's still like a z equals 2 here, but like we don't need to worry about that anymore. It's just kind of, it's still here, but I mean, we don't really need it to solve the rest of it, but for completion's sake, you can just keep that there if you want. You can instead multiply this row by 2, and you'll get effectively 2x plus 8y equals 16. And then you know, we don't do anything to the third row here after we've basically removed the z here, you know. Minus 3y equals 5. So then, if we just subtract this entire thing, or this entire thing, really doesn't really matter too much which way you do it. You know, I'm just kind of doing it, you know, either or kind of works. But we know that these two are the same, and these two aren't. Neither are these, but again, we're just trying to solve. So then we just get rid of these basically by like subtracting this row from this row, which then, you know, let's go ahead and do that then. Let's subtract this, the second row from the first row, basically p1 minus p3. Since this is still like the third row here, right? There's still like the z equals 2 in the middle here. The third row that we just are not gonna worry about too much, because this is all we really need to solve it. So when we basically get like, you know, 0x, we don't have to worry about that because that just kind of solves itself. We basically get 11y here, and then we have, since like this kind of equals, or we want to subtract that, so we basically get like 11 here, because 5 minus 16 is 11, so then we get 1 here. So, you know, we basically, the matrix that we have currently right now is, or not matrix, we haven't not gotten to that relation quite yet, equals 8, z equals 2, and y equals 1. Now, what do you think I think you guys can complete it on your own from here, because all you have to do is subtract this row, 4 of them, to this, subtract this row from this row. And you get x equals, well, of course, this is getting multiplied by 4, so we get like 4, so then we get this. Right? So when we have this, and if you plug all these in, so if we, if we plug all these in, so let's just start with the first one because it's easy. So basically we get, 1, because x is 4th, plus 1 minus 2. Hey, that seems to equal 0. That works out. So we get so then we have 4 plus 4 plus 4. Hey, that's 12 too. Awesome. And then 2x, 2 times 4, 8, minus 3, because it's just 3 times 1, minus 2, 2 times 1. Hey, that's we can fuse these together to be a -5 and then subtract that from a, and we get 3. That works, right? That's awesome. We got, this is it. This is the solution right here. But of course, there was a hugely easier way to solve nearly all this crap. And let's just go ahead and go back all in time to 3 minutes before my balls broke. So no longer, I still have my balls. It's probably 3 minutes, and let's try and solve this real quick. This can be simplified to an augmented matrix, not an actual one yet. And we write it as such. We're going to use this one here because I don't want to deal with that 4th here. And we've already simplified it a bit. So we basically have 1, 4, minus 4, 0 on the first row. 1, 4, 2, 12 on the second row. 2, minus 3, minus 1, 3 on the third row. And if we basically subtract them, get rid of rows, subtract rows together, well, we can just make this easier. We know, since these two are kind of equal, the original matrix, if we wanted to fill that out real quick, 1/4, 1 minus 1, 1, 4, 2, 2, minus 3, minus 1, 0, 12, 3. And then, then we just kind of transformed it using the same operation as this one here. And then we just do the same thing that we did before, except all I have to do is worry about these simple numbers, which we can go ahead 1, 4, minus 4, and then we can just go 0, 0, 6, because we want to subtract that. And then we have 12 here still, 0, 2, minus 3, minus 1, and now we just have to, so, we subtracted this from that. And then we just keep going from there. We just keep going. You can basically do it in your head. And again, this is what we do to show our work in our head, basically. So then we have 1, 4, and we basically have 1, 2 here, and then we just add 4 of that to turn this into 0. This is all 0, 0. Simplify that down. Add 4, so that's 8, and then 2 minus 3, 0. We add 2 to that, so we have 5 here. And then we multiply this row by 2, and then subtract that from here. So, so we have P3 minus 2p1, and we basically get 1 4 0 0 0 1, and then we have 0 for since we're trying to subtract that, we basically get minus 11 0, and the augmented matrix here we have 2, we have 8, and we multiply it, we basically subtract, so we have negative 11 here. And, we basically can simplify that to 1, 1. So then we have our final matrix here, 1, 4, 0, 8, 0, 0, 1, and then 0, 1, 0, 2, 1. Subtract the third row by this row, we get, basically the same answer here, 2, 1, and then we have this left over, we subtract 4, we'll multiply this by 4, subtract that, which then we get 1 minus 4 minus, so then we get this, which was fairly quicker, right? Easier, simpler. And so that was basically how we solved this in a bit more of a simpler fashion, a bit more easier. And we don't have to deal with all these variables, and we don't have to worry about like dealing with the weird algebra and like taking all our time on it. We just have to subtract rows and deal with all that. And that's the convenience of the augmented matrix that we have begun with. Now, there are a lot of stuff, including vector functions, multivariable functions that we can make using matrices. We have the vectors, linear geometry, direction vector. We can make planes, vectors, and spaces. And there's also Gauss-Jordan reductions here, which is another thing that I've completely forgotten most of my stuff about. There's also row vector rule for computing matrices, and there's a lot to linear algebra, but for the sake of beginning all this, well, that's basically the start of it. This is the very, very basics that you will learn, and to be honest, let's be real honest real quick. Now that you know what matrices are, you won't ever have to worry about this system of equations in any form, no matter how many variables it has, no matter how many rows of equations that you have. Because with the power of matrices, you can solve all of them for every single variable fairly easily. That's just how much time you're going to want to spend on it. Now, the thing is that now that you no longer have to worry about this ever again, don't worry about that ever again, you get to worry about regular matrices now. And you might be thinking to yourself, why, they just made life easier, What's the big deal here, We have, all this stuff here that's just, we know how to solve for all this. This is like a 3x3 matrix, just say. But, well, you gotta learn what matrix addition is if you keep going on, which is fairly simple. It's not that complicated. Matrix addition is fine. It's fine. But then you have to worry about matrix multiplication, which you can multiply it by a regular integer, n, and then multiply that. Or you can multiply it by another matrix, which is a bit of a pain because sometimes matrices can't really be multiplied by the other because their dimensions are different. Or you can do like a dot product multiplication. If I remember what a dot product was, I believe you multiply two different matrices together and get like effectively an integer value. And there's like inverse matrices where, there's inverted matrices, which isn't as simple as like swapping the numbers around and doing all sorts of stuff like that. It's significantly way more tougher for that to happen. Of course, you don't have to worry about all these matrix stuff, like matrix multiplication and addition, and like putting them in functions and doing vectors stuff. It's all fairly simple when you're being taught it, and all the basic rules will be applied to more complicated real-life applications, such as engineering, particle physics, all sorts of stuff, and also just number theory and like mathematics, pure mathematics. You don't have to worry about almost all that unless you want to pursue it further, because honestly, most of the, aside from the very, very basic introduction there of matrices, which simplify a pre-existing problem that you could represent with systems of equations and whatnot, there are a few things in real life that you could represent with a system of equations if you wanted to, if you could find an application to, and if you're aware of it. And something you can use, but most people don't because they just hate math. But you don't have to worry about it too much. All you have to do is just worry about your daily life problems. Most matrix stuff isn't going to help you with stuff like political scam callers who, from like random political organizations who somehow know my phone number and real name and like think it's I don't understand why they think that they do. Like, you're basically calling somebody who's going about their own day and trying to force yourself to make room to listen to your ramblings about some stupid crap that I don't care about. Like, I don't understand the appeal. Like, if your mission is to try and change people's minds and like try and get people interested or whatever, then you should probably target people who are actually like, if you're like, I'm imagining like, if they're not interested, then they're not going to be interested. Stop forcing it. It's like trying to force someone to like a dumb movie or a certain food that they never like. It's stupid. It's annoying. Nobody likes it. And eventually you're just going to find, and keep forcing shit, and nobody's going to fucking love you at all. But these people, for some reason, there's like there are organizations built around being a nuisance. And they somehow have my phone number and my fucking name. And they like to wake me up when I'm fucking asleep. I know it's the afternoon, but I have my own life. And these assholes have to fucking wake me up to do this shit? Well, I mean, it's not like I don't know their names, their family members, and whatnot since they decided to give me their phone numbers. So, I guess it's kind of even, though I can't really do anything with it, so it's kind of not even. I'll have a little bit of fun if I'm able to find what I can do with their information, but I mean, they have my information, and they decide to be an absolute harassing nuisance. I think it's fair game. So, that being said, though, matrix multiplication isn't going to help you deal with these annoying, harassing calls, and even if you tell them to stop, they won't stop. But, if you want to pursue it as a nice little fun brain challenge, if you want to learn something new, solve a few problems here and there, go ahead and pursue it. I think it's pretty fun. I like math, and I hope that you guys do too. But otherwise, thank you all so much for watching. Hope you guys enjoyed. Hope you guys learned something new, and I'll see you all in the next video, and if not, I'll probably see you somewhere else on the internet, or maybe not at all. So, bye!